Okay, so in our next example, we're going to still work with our vertex form, but this time we're going to see a change inside the parentheses with the x. So what happens if you add or subtract a number from the x inside parentheses? How does that compare to our parent function of x squared? Well, on this first graph, let's go ahead and put in our parent function. Parent function is at 0, 0, graphing pattern of 1, 3, 5, so up 1 to the right 1, up 3 to the right 1, up 5 to the right 1, graph your reflected points. And we're graphing in the parent function on this one so we can visually see how it's going to change when we graph g of x, which is x minus 3 squared. All right, well, who doesn't love a tricky x? So we're back to our tricky x. This is going to be a horizontal translation. So let's take some notes at the bottom of our graph. G of x is translated right or left. So let's decide, is it translated to the right or to the left? Because it's a tricky x, this minus 3 makes us think it should go to the negative side, to the left. But it's tricky, so it's actually going to go in the opposite direction of that. It's going to translate to the right 3 units. Our a value is going to be, when you have parentheses around your x like this, the a value is out front. Notice there's nothing there. So our a value is still a 1, which means our graphing pattern is 1, 3, 5. Oh, and we didn't talk about our vertex, or I didn't write it down. If you're taking our parent function and you're just translating it to the right 3 units, 1, 2, 3, that's where your new vertex is. So it's going to be at 3, 0. So that 3 is our h value. That 0 is our k value from our vertex. So let's go ahead and graph our g of x function. Vertex is at 3, 0. We're moving to the right 3. From there, we can do our 1, 3, 5 graphing pattern. So up 1 to the right 1, up 3 to the right 1, up 5 to the right 1 is off the graph. So let's get the points on the other side. Go ahead and draw in your parabola. And what we notice, how do they compare? Well, here's the original vertex. It just shifted to the right 3 units. This point shifted over to here 3 units. This point shifted over here 3 units. Every point in the parent function just got translated to the right 3 units. One thing that does change with a horizontal translation is your axis of symmetry. The axis of symmetry for the parent function is at x equals 0. Well, if you shift your graph to the right, that axis of symmetry shifts with it. So now our axis of symmetry is at x equals 3. And so remember in our definition video, our vocab video, we said the axis of symmetry was at x equals whatever your h value is. It's always going to be the x coordinate of your vertex. So our axis of symmetry is x equals 3. So that will change with a horizontal translation. All right, so part B we can run through a little bit faster because we won't graph the parent function. We'll just graph our h of x function. So h of x equals x plus 1 squared. So what we notice is we have an x plus 1. That is a horizontal translation. So h of x is translated, and then we decide left or right. Well, if it's x plus 1, we are going to go in the opposite direction. We're going to translate to the left 1 unit. Our a value is going to be in front of the parentheses. There's nothing there, so that means our a value is equal to 1. So it gives us a 1, 3, 5 graphing pattern. And then our vertex is going to be, if we're shifting to the left 1 unit, negative 1, 0. And let's just make sure we're still seeing, or just recognizing that's an h and a k value. Our axis of symmetry will be at x equals negative 1. Okay, well, let's actually graph this then. We shift to the left 1 unit. There's our vertex. We said we still have the 1, 3, 5 pattern. So up 1 to the right 1, up 3 to the right 1, up 5 to the right 1. Get your reflected points. And here is our h of x function.